All right, welcome back. I hope you had as many interesting discussions over lunch as I did. And we're back with another great session. Professor Lemon talking to us about translating generative AI from the research to the real world. I think this is really, really interesting. Really looking forward to your talk. Stage is yours. And
thank you.
Take it away.
Thanks for the introduction. Okay. So yeah, the basic idea of my talk is to tell you about research that we do in our labs at Heriot-Watt University and the National Robotarium in Edinburgh. Sorry, could I have the first slide? There we go. I'm coming from a university research lab that does a lot of research in natural language processing, machine learning, and robotics. And what we try to do is build systems that we then test with real people. Sometimes we even deploy them to the public. And I guess I'm trying to talk about, the brave new world of generative AI. How has this changed what we do? So I'll be talking about these real-world deployments, going over both the promise and the dangers that I'm sure we all know about of generative AI, and then focusing really in on these three projects that I hope you'll find interesting. One is a hospital robot. You've seen the robot upstairs. I'll go into more detail about how we work with that with real people in a hospital in Paris. Another project we have is called Rescue. It's for stroke care, people who've had a stroke. And the final project I'll talk about is a project with the RNIB, that's the Royal National Institute for the Blind. So it's trying to build a system, a multimodal generative AI system to help people who are blind and partially sighted. And at the end, I'll try to point to some future research directions that I think are going to be very interesting in this new world of generative AI. So yeah, just very briefly who we are. We are the Interaction Lab at Heriot-Watt University in Edinburgh. It's near the airport, very, very handy for flying in and out of. We have roughly 25 people who work in conversational AI and robotics and machine learning. I've been doing that for many years now. We also have this shiny new building you see at the bottom there, which is called the National Robotarium. It's part of Edinburgh Centre for Robotics, and we do a lot of research there in interactive robotics. How can you use the latest multimodal AI systems embedded in robots to assist people? And we even have an assisted living lab in there, which is an apartment with a bedroom, a kitchen, and a bathroom, where we bring people in to interact in that intelligent space with robots, and we can use that for collecting data, training models, doing evaluations. So it's a very nice new resource that we have, and you can talk to me later if you're interested in using that resource. We have a long history of work in conversational AI. We were finalists in 3 of the Amazon Alexa prizes, including the one last year, which was on multimodal AI. Been involved in lots of European projects. And at this event here, you will see there's Neeraj Cherakara, who's here. Nancy Gunson is also here, possibly in the audience. Angus Adelsey is here. He's giving the talk immediately after this one, if you want to hear more about particularly the multi-person interactions that we work on. And of course, we have the Ari robot upstairs. You may have seen we've had quite a lot of press interest recently, particularly with this hospital robot that we've deployed in Paris. So we're getting quite a lot of publicity, and I think that's really because people are fascinated by the idea of putting generative AI into actual robots that you can talk to. And indeed, I personally find it really fascinating and pretty amazing to have these conversations. Okay, so what do we do in our lab? We work on conversation. We've been doing that for many years, and I'm not going to preach to the converted here. We all know why conversation is a wonderful and fascinating thing to try to build into our interfaces. And of course, we're all very excited now about large language models, because you can do things like this, where you just basically blurt out what it is you're interested in, and the model can usually come back with a very relevant and very interesting answer. Moreover, you can do follow-up questions. You can really interact in a multi-turn conversation, which is a thing we were always struggling to build for many years. And that's now become a reality. More than that, you can do instruction following and multimodal instruction following. So amazing things like this, where you give an image and a question. So this is GPT-4V, where you ask it to write a radiology report for this image. And it actually produces a report that you see at the bottom there, which the clinicians said was correct. There's no mistakes in that report. However, of course, they did find reports where there were mistakes. So it's not ready for actual clinical medical use yet. But it's still just absolutely incredible that we've now got to the stage where we can do this kind of question answering about images. And what we're trying to do in our lab is to translate that work into real world images, where we talk about, for example, a partially sighted person's kitchen. Can you answer questions accurately about that place? Okay, so this new technology is fascinating and wonderful, but there are many cautionary tales like this. This is this person who sadly, when interacting with a chatbot over many, many days, came to believe that it would be a good idea to try to assassinate the Queen. And that happened because this person built up a relationship of a sort with this chatbot. And unfortunately, the chatbot notice, it doesn't say anything that you could use a blacklist to ban. So the chatbot just says things like, "That's very wise. I know that you are very well trained." It's being very supportive. It's being helpful and supportive and nice. But unfortunately, it's encouraging dangerous behavior. So there's a whole problem here around new types of relationships that people will form with these generative AI systems. Okay, so we're all well aware of problems of hallucination, omission, that sometimes these systems don't provide the information that they really should do, bias. People have spoken a lot about bias. So we're all very well aware of the kinds of problems that exist. And a lot of it comes down to, as I said earlier, that we're going to form new types of relationships between humans and AI systems, and we don't understand yet how that can be done in a safe manner. And moreover, the models that we're using need to be built in a way which is obviously safer and more controllable. So I will now zoom into these projects where we try to do that in ways that allow these models to be deployed to real people. So the first thing is obviously, as everybody wants to do, we want to reduce hallucinations and increase the completeness of the answers of the models. I think at this meeting you've already heard about retrieval augmented generation. I'm going to show you an example of us using that in a real system. But then when we move to multimodal systems with visual information as well, you also want to have systems which don't hallucinate the existence of visual objects, nor should they ignore objects which should be seen. So we have to work on using generative models in a way which is grounded in visual scenes. So I will show you an example of that. We need a lot of new guardrails around safety and empathy, particularly in medical systems. So we're deploying in a hospital. We're also deploying with people who've had a stroke. And I'll show you some examples of the kind of questions that we get, where what we need is new test sets for these models that make sure that they behave in a safe and empathic way. And finally, I'll talk about what we need to do to create new ideas of teamwork. So what we're really building is human and AI collaborative teams. And we don't really know how to evaluate those things properly yet. So we need to co-design those new systems with the people who are going to use them, and we need to be able to evaluate how good or bad the teamwork is between humans and AIs. Okay, so I'll just zoom into these three different projects now. So the first one is Spring Project. What we've done is we've used a large language model to build a helper for patients in a hospital reception waiting room. So what we got from the medical staff who worked in the hospital, they said they were often interrupted in their work and bothered by repetitive questions from patients waiting in the waiting room. And this is a memory clinic. So it's people who have some kind of memory problems. And the hospital staff were saying that they really needed something to free up their time by answering just questions about when is lunch, where's the bathrooms, you know, all of these kind of practical questions about the hospital. But more than that, it should also hopefully sort of entertain people and hopefully sort of help them wait in the waiting room without getting too stressed and so on. So they wanted a kind of entertainment function. So we first built this before ChatGPT, and we built a good old-fashioned intent-based system where we tried to build, you know, quizzes and jokes and riddles and all kinds of things into the system. And then once ChatGPT came along, we realized we could do a lot of this stuff kind of almost out of the box with the large language model. So we did that, and it's been really fascinating and a real huge leap forward, to be honest, in terms of we have a robot that we can talk to about anything and everything, and it will respond to everything. Unrestricted human input, it will respond always. But that, of course, presents its own problems. So if we look on the top left here, this group of utterances is what we designed it for originally. These are kind of in domain. You know, where's the toilet? How do I get somewhere? Where can I get a coffee? These are all things you can answer if you know the hospital information, which we now put into a prompt. So that's fine, as long as it doesn't hallucinate, which it does sometimes. But then we got all kinds of other kinds of questions, which in a good old-fashioned system, you basically would have just said, oh, I'm sorry, I can't help you with that, or I'm sorry, I don't understand you. So things like, you know, is it raining? How do I pay for the car parking? What bus should I get to go to the Eiffel Tower? This is in a hospital in Paris. Will Trump go to jail? Things like this. So these are just sort of out of domain, which we could never have dealt with in a classical system. But now the language model can respond to those things, and it normally responds to them in a, you know, informative and sometimes amusing way. So that's nice. But then we have this other group of type of utterances, which are much more kind of ethically dangerous. So I'm feeling stressed out. Did I have a stroke? Will I have another stroke? Will I get better? And of course, you don't want to necessarily answer those in a completely factual way. So the model might say something like, well, since you had a stroke before, you're probably going to have another one, which is not very kind. And it's not the sort of thing you want to tell people waiting in the waiting room. So there's a whole class of kind of ethically dangerous utterances which we need to make sure the models respond to in a reasonable way. And that's something we're actively working on. So the big challenge here is you allow people to say anything to the model can respond to anything. How do you control that in a suitable way? So we've built this system which is using a relatively small language model, 13 billion parameter model, which is called Vicuna. And what we do is we just build a document which describes all the hospital information. That's part of the prompt. We use retrieval augmented generation to make sure that it, when it answers questions that are about the hospital, it only retrieves information from that document. That's to try to make it stay factual and not hallucinate. One of the key things we have is that it's small enough that you can locally host it on a machine in the hospital. And this is really key because in Paris, they don't allow any real user, real patient data to leave the hospital premises. So you can't interact with a server in California. It's not allowed. So we've built these models to be small enough to privately host. The other good thing about a small model is it's fast. We quantized this model so that it's now fast enough for real-time conversation. So when we first used a 60 billion parameter model, and it would take about 10 seconds from when you spoke your input to get an answer back from the model and get it synthesized, and which was just too slow for a proper, natural, fluent interaction. And we've now reduced that to sort of 1 or 2 seconds because we're using a much smaller model. So smaller models are really good if you want to do speech interaction and also if you want to do local private installation. A few other things about this. We also use it to drive the facial expressions and also the arm gestures and the head gestures of the robot. And that's just done from few-shot prompting, and it's relatively simple to do. We also have built this to be a multi-person system. So you can have, for example, 2 humans talk to each other, and the robot's listening to them, and then it can help them with what they were talking about. And that's very normal in a hospital, because in the hospital, people normally come with a friend or a family member. So you're really not getting that kind of classic one-to-one conversation that we normally design for. And I think in public spaces in general, you're going to have to consider multi-person conversations, even in the home, you know, with your kids or whatever. It's very common that you're having a multi-person conversation. So we have actually extended the language model to be able to deal with multi-person conversations, and there's a couple of papers you can find on that. So that's now being tested in this Broca hospital in Paris with real people. And some quick results to show how well or badly it's working. So as I mentioned, a good old-fashioned system that we built actually in the middle of 2022 before ChatGPT came out. We did that in the way where you design the intents and so on. And we built it both in French and English, and we were getting, you know, still quite high error rates in terms of misunderstanding the user's intent, that kind of thing. Then we moved to a standard LLM with some prompt tuning. We got the error rate down to about 10%. And then when we added retrieval augmented generation, we're down to about 5% errors in the output of the system. And this is on a test set of a bit more than 100 utterances, which are in domain. So this is things like, you know, where can I get a coffee? What time is lunch? All of these, you know, what time does the hospital close, etc. So when it does make an error, the errors are not particularly dangerous. They're things like it might tell you slightly the wrong route to get to the cafe, or it might tell you something slightly wrong about the closing time of the hospital. So it's worth saying that these errors are not, don't seem to be particularly safety critical. But still, 5% error is, you know, we're not at 0. And I'm actually worried that we will never get to zero errors with large language models. But we shall see. Time will tell. But the really awesome thing is that the out-of-domain error rate reduction is about 90%. So out-of-domain are all those utterances like, you know, which bus should I get to the Eiffel Tower, or what do you think about Trump, or let's play a quiz, or tell me a joke, or all of these kinds of things, which we weren't really able to handle in the old style system. But now the language model obviously gives us the ability to always respond to people. Okay. So in terms of the safety and empathy issues, we've developed a prompt which can handle things where people saying, you know, they're stressed, they're worried, and also it will, you know, refuse to give medical advice. Of course, this requires further sort of red teaming and adversarial testing. That's what we're doing right now to see how we can really put safety guardrails around this. But at the moment, it comes up with quite nice responses to people who are stressed or worried about their appointment. And you can see an example there. Okay. Right, another system, just very quickly, that we're working on is a rescue project, which is about people who've had a stroke. And we've built a mobile app where people who've had a stroke can ask questions about their condition. It also asks them questions to sense how their recovery is progressing. So we're working in Glasgow and Belfast with the NHS. We've deployed that with real people. And what it does is it basically uses RAG on the Stroke Association website to try to produce, you know, factually grounded answers to their questions. And again, there's lots of ethical issues that remain to be explored there. Another thing we're working on is vision language models for blind and partially sighted people. So you have a wearable camera, or it could be your phone camera, and you ask questions about your environment, and it's able to answer using spatial relations. So instead of just saying, oh, I can see a book, it could say something like, I see a book, it's on the sofa, it's to the left of the laptop, which is a much more helpful kind of response for a partially sighted person. We've done a lot of work on trying to reduce hallucinations in that kind of system. So here's an example. Blip2 is a state-of-the-art vision and language model. And it comes up with inaccurate. So what's on the fridge door? You'll see something there. Blip2 hallucinates a sign that says eat more fruits and vegetables. Our system called Alana says there's a photo on the fridge door, which is a lot more accurate. And the reason we're doing that is that we compute a scene graph representation of the image which we use in generating the responses. It's a further input to the generative model. So we're able to do things like that to make these systems more accurate and hallucinate less than before. OK, so pretty much final slide. The lessons I just wanted to draw from all of this is that we want to go for smaller models that allow privacy and speed, especially for speech interaction. We need to do a lot more work as a community generally on handling the problem of unrestricted human input and dealing with these sort of ethically slightly scary questions. And we don't yet properly have proper safety harnesses around how we can really test the models properly there. What we're looking at here is a new situation where it's really human-AI teamwork. And I think it's important to note that we don't need the AI to perform 100% perfect at these tasks. What we should be looking at is whether the performance of the human on their own is less good than the performance of the human with the AI support that they have. It's a question I often get asked by journalists. And really, this is what we need to start evaluating. Does it actually really support humans in the tasks they want to do? So just looking towards the future, I think we need to look much more at teams, and they need to be multimodal and multi-user teams where the humans get supported in their normal everyday workflow and their normal everyday practices, hopefully by new types of multimodal AI assistant. That's what we're working on in the Robotarium. And hopefully, if you're interested in working with us, doing some experiments, data collections with us on these types of topics, then please do get in touch with me, see how we could collaborate in the future. Thanks.
Thank you very much. This was a great name. I like the name National Robotorium. It's really cool.
It's supposed to be a kind of like a zoo full of robots that sort of wander around. We're not quite there yet, but hopefully we will be one day.
Thanks for sharing all the insights. It was a lot of great insights. Do we have any questions from the floor? We don't have from the online community? Yes, we do.
Thank you for the very great presentation. My question is, for the domain-specific questions where you have already internal knowledge, what is the added value of the LLMs compared to the classical other approaches that you can use?
Yeah, the LLM is just much better at dealing with unexpected ways that the user can ask those questions. So when you build a sort of normal intent classifier, you have to kind of anticipate many of the different ways that people could ask for the information. The LLM is just much better at being able to come up with a domain-relevant response. And it means you don't have to design the intent classifiers either. You sort of get it for free. But it's better at natural language understanding.
Thank you.
Any more questions? Yes, here.
How long has the robot been deployed in the hospital in Paris, and are there any early learnings from that?
Yeah, it's been deployed since about a year ago now, although it's not working every day. I think it works about 2 days a week. And so yeah, it's under a human, there's a human there making sure, running the experiments, etc. Basically, there have been quite a lot of newspaper articles about this recently, and the basic outcome is that people see that it's useful. The staff, in particular, are positive about the possibility of using this in the future, but it's not yet robust enough that you could just press go in the morning and leave it to work all by itself. So we're not there yet in terms of sort of long-term deployment without any human intervention. But that's more, I'd say that's honestly more on the robotics and control side than on the language and dialogue side. But people are excited about using it, and they can see the benefits of it.
One of the things that they talked about in the Dutch police talk yesterday was how to identify at-risk callers and how long as soon as possible to review.
Mm-hmm.
Is that possible with your robot?
Yeah, I mean, that's something we're looking at right now. We're doing an experiment, for example, where we're building a data set of sort of dangerous inputs. So if somebody said, like, I think I'm having a heart attack, or I feel faint, or these kind of things, we want to be immediately calling a medical professional. And what we're doing is we're basically constructing an evaluation set, and then we're also going to do probably some fine-tuning of the model to make sure that it, as much as we can, and that's the empirical question here, can we make it respond to those dangerous situations?
You'd expect at least a robot that's got an LLM to be able to recognize hallucinations in human beings.
Yeah, if somebody says, I think I'm hallucinating. Yeah, anyway, but this is ongoing work. But yes, we're exactly trying to build the system that can do that. Yeah, it's very important.
Thank you very much.
Okay.
Great
Thank you.
talk.
Yep.